that we can't write to that directory. But why? Well, if we pull up the AppArmor rule set for MySQL D, what this is doing is it's adding another layer of permissions on top of your usual chmod. In this case, it's pretty simple. It's just saying, it's giving it read write or read access. Now, one important thing to note are these includes at the very top. What these includes are doing is it's allowing, this particular include is user temp. And this is giving it read write access to /tmp. So this is a safe location where we can write files. This vulnerability in AppArmor is systemic. It affects, as far as I know, all installs of AppArmor are affected by this. It is very common that a process needs to write to temp because it is a common requirement. So it's commonly that processes will have will be including this user temp file. But this whole idea, AppArmor is trying to separate processes. But by creating header files, you're creating unions or places where two processes have have an overlap, where we can write to a directory /temp and then we can execute that file. So in our union select, if we change it to if we change the location to /temp, the query succeeds. Well, okay, so we're able to upload PHP code, but now what? Well, using a local file include vulnerability, we're able to execute this code. So basically with a local file include, we're able to give it a path of PHP code and have it executed. So using this very simple chain, we use SQL injection to be able to drop a file, and then we can use a local file include in order to execute that file. And this bypasses AppArmor. So far I haven't heard back from the AppArmor team, but Ubuntu is Canonical is very interested in this vulnerability. Their bug response team is fantastic. I just like talking to them. There are cases where it's hard to say who has a better bug response, either Google or Canonical. 10 minutes. But I would audit their software for free just to talk to their bug team. It's that good. So now there's another filter in this case. It's looking for union. Simple cases of union, %20, union with comment marks, or just union. Well, there's one thing that's very simple. What about union with only a comment on one side of the union, of the actual union statement? This is very simple. It's literally just a very minor change to the to my query. I was able to bypass this very simple filter. Now there's other cases. So what if this application didn't have a broken authentication and session management? There are other ways to gain access to the administrative area. That is using CSRF. Using CSRF, if we can trick the administrator to click on a link while he's logged in, then we can force him to carry out the request. So we can force him to carry out both the SQL injection and the local and file include without having to worry about without having to worry about the consequence. Without having to worry about the first part of the chain, which I did manually. Now, there's another thing. This application doesn't have any CSRF protection in the anywhere, absolutely anywhere. But if it did, you can use XSS in order to gain CSRF. This attack was actually used by the SAMI worm, where it was able to use XML HTTP request to pull out the CSRF token to forge the request. Now there's another attack, is DNS rebinding, which is very popular from Dan Kaminsky. This would also allow us to attack this administrative interface. So I wrote an exploit against phpMyAdmin in which they did have very good CSRF protection for most variables. They did, however, have a whitelist here where any variable name on this list could be sent from any domain. It was exempt from the CSRF token. So in this case, DB and table were actually vulnerable to SQL injection. This is not, I couldn't just execute any query, but I was able to influence a query that was being built. So in this case, DB has to be set to any database, in this case, information schema. And table, I'm filling off the query. This is doing a union select into out file. So using local file include, we can gain remote code execution on a remote system. AppArmor will not allow us to write to /var. Anyway, there's another thing to note. SELinux is far more secure than AppArmor. And SELinux will throw this error when trying to pull off this attack. Although it will allow MySQL to write to /temp, what it does is it looks at the source, it looks at the owner of the file. So it's saying, hey, MySQL owns this file, but it's trying to be executed by HTTPD and throws an error. Now there's an important thing to note. SELinux throws a whole lot of errors. It throws errors against, in fact, it will not even let you install PHP nuke because of errors. You have to add an exception. It's common because of this restriction that people just get upset with SELinux and install it altogether. And that is a flaw in SELinux. I will admit that. Although it breaks my exploits, and it breaks this exploit in particular. But under the 7.0 branch, there is a very nice eval remote code execution. I was running an old version of PHP BB, which using preg replace /e. With the /e modifier allows you to eval whatever parameters are passed to it. So in this case, this actually does work with SELinux. We don't have to introduce new code; it's already there. We can just access it. Now, there's a very cool paper, a study in Scarlet. This paper is a bit old, but when I read this, it was a precursor to writing my first exploit. I highly recommend that you grab a copy of this paper. It goes over a lot of the syncs and problems with PHP, such as preg replace /e. Anyway, that is my talk. Thank you.